Okay. Hello, Dr. Gilmack coming at you today, and what we're going to talk to you about is something that's a little more advanced than we normally do on this channel, but I ran into this with my statistics class the other day, and I just wanted to address this for everybody who follows, right? So, a lot of times we'll do a block design ANOVA, and we'll try to pull out some of the variance that's being caused by something we know is contributing to the response variable. And so you'll block according to that. Blocking is very similar to pairing in a paired t-test. And so what you do is you're pairing the data on this contributing variable, right? Now, in a paired design, the sample sizes have to be equal. Well, what happens when you have an unbalanced block design and all of the treatment levels, all of the factors are not of equal size? This is a problem, right? And so how do we resolve that particular issue? Um, Now, I have a document. I probably will share this document about understanding the unbalanced block designs and the linear framework and such. And so this is going to be here. But what I really want to do is, how do I practically approach this unbalanced design? How do I do a block design when everything is not equal? And it turns out that we're going to turn to our old friend, the linear model, and we're going to do a type 3 sum of squares, okay? And I'm going to explain that in a minute. Now, here's the issue. This is the wage data. The wage data is common in the R package. It's one of those data sets that gets used in a lot of statistics classes, and StatCrunch is a Pearson product. It's a very common way for students, introductory students, to do it, but it also demonstrates the problem that we have with an unbalanced design. So here, let's say that I'm going to do my ANOVA, and if you're going to do an ANOVA with a blocked design, that is a two-way ANOVA. So we're going to click on two-way. Now, so I can't use year. I could use age. This is the log of wages, but let's just use wages as a quantitative response variable, which is appropriate for an ANOVA. And then let's say that in the row, what you wanted to analyze was the education level, all right? And so typically we would put this in first because this is the treatment. And then we would block by, let's say, job class, right? So we're going to block by job class, okay? Now, when we do it this way, we're doing a type 1 sum of squares, which is sequential. So see, we're going to sequentially add the factors to the model, and there's a dependency to the order. So I did these in this particular order to do that. Now, in StatCrunch, when you click the fit additive model, that takes out the interaction and it's going to remove variance from the model from job class and then look at education, okay? And when I click on compute, it says this isn't permitted with unbalanced designs. All cells must have the same number of operations. Well, that's sad. Now, if you unclick this and you click on compute, you do get a two-way analysis. But you'll notice there's an interaction term here, and that interaction term means that I'm actually looking at education and job class both as treatments. I'm no longer blocking on job class. So how do I fix this, right? How do I fix this? Well, it turns out that what we want to do is use a linear model, and it turns out that we want to use a type 3 sum of squares. And there is a reason why we use the type 3 sum of squares. The basic reason is it accounts for all of the factors, including interactions. It is not sequential, and it uses the unweighted marginals. So you do violates testing main effects. Yes, right? So it's good for unbalanced design and testing main effects regardless of interactions, okay? So that is the benefit, the common use, is for unbalanced designs and testing main effects. So here my result is there is an interaction. So if I remove the job class, I will only be looking at education regardless of this particular interaction. So I want to use a type 3. Now it turns out that you can't do that in something like StatCrunch. So what are your options? One option would be to straight go to R. So I could go, let me scroll up, right? Here's our blocked. This is from a project, and so I want to make sure that, yeah. So here I'm using the car library for Levine's test, but also for this blocked design of the linear model, okay? So in R, you need the car package, okay? And then we're going to go to our Blocked ANOVA. And so I've already checked the assumptions. We're going to continue this analysis. So here from the car package, you can do ANOVA. I first ran this with a lowercase a. The lowercase a ANOVA is a different function, and this will not run. R is case sensitive, and so the A needs to be capitalized. LM stands for linear model. Remember, we're looking at this from a linear model perspective, and so that's going to help us out. And what we're going to do is we're going to take wage, and we're going to predict it from education plus job class. So I have my actual treatment and then my blocking, okay? And it's going to be a type 3 analysis. So the linear model is encased in a set of parentheses, comma, and then type 3 for our type 3 partial sum of squares for the unbalanced design and testing these main effects. And then all you have to do is go ahead and do the wage blocked. That will show you the output of the ANOVA. I'm sorry that some of the clicking is causing pop-ups. And here's our type 3 test. And here we have our education and job class, and we can read this as normal. The intercept is here because, again, we're treating this like a linear model. So there is an intercept there. But really, the only thing that I want to interpret is the education. Now, this can be a little intimidating. There's a little bit of a learning curve. The code in the package here is not really that hard. But if you're doing a different data set, if you're doing a different analysis, right, you might get some error messages and that might be difficult, right? So how can I do this in a tool that looks like StatCrunch but allows me the flexibility of R? Well, there is a great tool for that, and the tool that I've been recommending to my students for a while is Jamovi, okay? Jamovi actually is a graphical user interface powered by R in the background, and this is an open source community, and it wants to create open statistical software for people, all right? Now, there is a cloud account. All right, so you just sign up. It's free. You can use their servers and you can run it. This Jamovi Cloud is great for iPads and Chromebooks where you can't download software or it might be difficult to install software. If you have an institutional laptop and you can't install software on it, this is a great option. Sorry about that. You would just start. You're just going to click on start. And you're going to create an account and log in. It knows it's me because I've done it on this computer before. And so you would just click on continue. And it's going to start the session. And here we go. Okay? And so you can do pretty much everything in Jamovi Cloud that you can do in the desktop version. I am going to go ahead and switch over to the desktop just to show you for some stability reasons. Okay, so I'm in Jamovi desktop. again, this is going to be exactly the same as your cloud edition. Um, Please note, I do have some additional modules over here. I have a different video that talks about Jamovi and the modules and some of the other things that you're seeing on the screen. But here's what I want you to pay attention to, right? We're going to click on the hamburger over here. And in the hamburger, you can do an import. They have changed this recently to special import. I don't know why. I think maybe it uploads more different file types. But if you click on import, you have the option from this PC. I'm in my download space. The OMV file is a Jamovi file. You can see that CSV files are going to be perfectly okay. Excel files are going to be perfectly okay. This text file is something that it can handle at least to a certain extent. And so you've got a lot of different file format types that Jamovi will handle. But here's our wage data down here, and I'm going to click on it, and it's going to import it. Now, it defaults to having A, B, and C, and so it's pushed this data in here. So what I want to do is let me get rid of A, B, and C, right? So up here, I'm going to click on data. It's already on column A, and I'm just going to click on delete, and it's going to ask me to delete it. I'm going to delete column B, and I'm going to go ahead and delete column C. And now you can see here's my year, and it's showing up as an ordinal level variable, right? So let's see the setup. Oh, nominal. It's a nominal level variable, right? I can close this out. Here is age, and then age is a continuous variable, which is pretty much true. And then I have some categorical variables. So here's marital status. And again, if you click on setup, it's a nominal. So you can do nominal, ordinal, continuous, and then just an ID sort of variable. And these are important because you want to make sure that you have the correct level of measurement in your data set. Otherwise, some of the functions will not work correctly. Now, if we scroll over, here is our education, here's our job class, and then here is our wage over here. So what we're going to do is I'm going to kind of scooch this over just a little bit, and we're going to click on analysis. Now, this is a very menu-driven sort of statistical program. It's very much like StatCrunch or Minitab or SPSS. And so you're going to click on ANOVA because we're doing an ANOVA. We are not doing a one-way. We are not doing a repeated. So we're going to click on this ANOVA, and this is going to give us some very nice features here. Now, it's going to ask for the dependent variable. It's got to be one of those ruler or continuous variables. So I'm going to scroll down. I'm going to click on wage, and I'm going to go ahead and click on this arrow to go ahead and put it in the dependent variable. So the ruler matches the ruler, and so that's perfectly okay. Then I'm going to do education and add it to my factors. And then I'm going to take job class and I'm going to add it to my factors. And again, anything that's of the nominal or ordinal level is going to be okay. And so these pictures are perfectly okay. So, and you'll see that now I have done a two-factor ANOVA and I have the interaction term here. Now, this is the part that I want to get rid of. I am not wanting this. And so what I'm going to do is I'm going to go down to model, and I'm going to click on that interaction term, and I'm going to remove it. And you'll see that the sum of squares that it's doing is type 3. I have the 1, 2, and 3 option. I'm going to leave it on type 3 because that's the type that I would like to do. Now, the very nice thing about this ANOVA is if we went back to my R code, the assumption checks were in a separate code block, but I can do my assumption checks and my post hoc analysis is here. For this one, I was only caring about education, so I will go ahead and add it over here. And I have the Tukey, but maybe it's more appropriate to do a Bonferroni because I don't have equal sample sizes. And so now I have my post hoc table over here. The estimated means, you can get those if you would like, and a bunch of other things that are in here. But those are the basic things that you would do in sort of an undergraduate statistics class. And so there it is. Now, once you have this, you might say, well, now what do I do? Well, if you right click on it, you can copy the table, you can copy the analysis, and then you can paste it into whatever Word document or Google document that you would like to make sure that it's there. If you're just doing this table, you can go ahead and export it, and you have a chance of exporting it as a PDF, a web page, that Jamovi, right? LaTeX and R object. So you've got a lot of different ways that you can export it and use it as you go forward. All right. So we've talked about block design. I've showed you how to do it in two tools, briefly in R, but I really paid attention to Jamovi. If this was helpful to you at all in any of your projects, that really makes me happy. I'm really just doing this to help students. And so if you got something out of this, leave me a comment because that's really what I'm doing it for. Thanks and have a great one.